You have for sure heard the question, why is it the case that some regions of the world are so much richer than others? What determines the differences in the quality of life and in productivity of different regions of the world? That's one of the foundational questions of whole economics. And I'm going to just shed some light on this question by taking this approach that I was advocating throughout the series. Namely, I'm going to refer to the history of technological revolutions. The timing of technological revolutions is one of the key determinants of differences in level of development. The agricultural revolution was first in the Fertile Crescent in the modern-day Middle East, and later there were separate agricultural revolutions in other parts of the globe. Notably, the second one was in modern-day China. The agricultural revolution determined that the Middle East, including Egypt, including also parts of the Mediterranean basin, remained the most populated region in the world until the moment when it was overtaken by China, and then China remained the most populated region in the world, at least until the year 1500, when you had yet another technological revolution, the scientific revolution. And that led to technological primacy of Europe throughout the next centuries and allowed setting up colonial empires. The Industrial Revolution, which, as I argued before, opened the dimension of development related to GDP, the Industrial Revolution appeared first in England, then spread throughout Europe, and established economic primacy of Europe, and then European offshoots as well for the centuries to come. The Digital Revolution, in turn, appeared probably, as we should say, mostly in the US, the main hub of research and development, and the main hub of data concentration. Creation of value added in this sector is in the Silicon Valley, and that's in the US. Each time there is a technological revolution, first you observe that a leader country, a leader region of the world takes off and increases the level of development, whereas the followers lag behind, and that builds up divergence, that builds up the distance between the two regions. After the key fruit of the revolution have been reaped, like this here, growth in the leader region slows down, whereas the follower catches up by eventually adopting this new era and switching to the new technology. So you have a cycle of first divergence and then convergence, or when the distance first grows and then shrinks. We call that beta-convergence because that's a phenomenon where the growth rate depends negatively on your starting point. So the lower you are, the faster you grow. That's what you observe in this section of this figure. However, there are feedback loops. So you can imagine, like for example, after the Industrial Revolution, that opened a new dimension of development, GDP per capita, and so earlier achievements in terms of population size and in terms of scientific knowledge, they fed into the creation of the new dimension, new technological dimension. But then after the Industrial Revolution has occurred, you had this series of feedback loops. So there are also important impacts of GDP growth on population growth. Notably, you had this population explosion after the Industrial Revolution. Mortality went down a lot and fertility adjusted way later. Another thing is that thanks to better lab equipment, you had better achievements in terms of scientific knowledge. So, these feedback loops were observed across all the technologies that were present after the Industrial Revolution. That's really something universal. Technologies from the next era feed back on the previous era. After the Agricultural Revolution, you had an increase in habitable areas, such as, covering previously sparsely inhabited steppes, which have very fertile soil with agricultural land. If you think about the scientific revolution, that helped increase the population size, thanks, for example, to the use of fertilizers, or the decline in mortality was because of developments in medicine. If you think about the Industrial Revolution, then you had an increase in population, again, to a certain extent because of mechanization of agriculture. You also observed an increase in scientific productivity. The increase in scientific productivity was, for example, because of greater investments in lab equipment. Finally, the digital revolution again led to a massive increase in GDP per worker. This was because of reduction in costs, because of better information transmission and collection. Robert Solow may have said in 1987, "You can see the computer age everywhere but in the productivity statistics." But nobody would dare to say this today. Recall, though, these are only second-order effects. First-order effects are observed in the new dimensions that are created thanks to the technological revolutions. Thinking about the inequality in terms of income and productivity, one has also to take into account the fact that technologies from different eras tend to coincide in time. Here you have a schematic graph of the coexistence of technologies over time. So I have marked on the horizontal axis the consecutive technological revolutions. And so you see, in the beginning, we only had the hunter-gatherer technology. So that was 100% of all our technologies in terms of the era from which they originated. But then, of course, after the agricultural revolution, more and more people were employed in agriculture using what we may, from today's perspective, call basic agricultural technologies. Then you had the scientific revolution, after which you had a much better accumulation of technological knowledge. And for example, in agriculture, that knowledge has also been used. And outside of agriculture, you also had an increase in crafts and trade. Now later, thinking about the Industrial Revolution, then, the advanced agricultural technology, the one from before the Industrial Revolution, began to fade, and it was replaced by industrial technologies. And again, after the Digital Revolution, you had the emergence of digital technologies. And assuming we are about here, we can say that at this moment you observe that digital technologies are on the rise. Agricultural technologies are still present. For example, it's estimated that about 70% of people in sub-Saharan Africa are still employed in subsistence agriculture. But in fact, all the world, including sub-Saharan Africa, to an increasing extent, uses also digital technologies. And if you observe the development across the developing regions, for example, as documented by Hans Rosling in his great book, Factfulness, in fact, you see a lot of convergence these days, thanks to the mature digital technologies that spread throughout the world, and also thanks to the advent of digital technologies, which have a shorter diffusion period than industrial technologies. Within each consecutive technological era, technological progress and economic growth accelerate by at least an order of magnitude. This means that whoever is the first to begin a new technological revolution has a great advantage in the beginning. This head start makes them run away far, makes them grow much faster than any other region in the world. So the mechanics are always like this. First, the rich escape, and then the poor catch up, and eventually you would have perfect convergence, if not for the fact that in the meantime, you already have yet another technological revolution which enables the rich to run away once again. Of course, I have not addressed the question why some technological revolutions appeared in this part of the world and not the other. We don't know really. The only thing we know, like almost for sure, is the origins of the agricultural revolution, because we know that the key determining factor was biogeography, in particular the presence of certain crops that could be domesticated. So populations that happened to live in an area where you could find like wild wheat or wild rice, they had an advantage over, like, for example, Aboriginal Australians who didn't have this kind of luck. But if you think about further technological revolutions, like why was the scientific revolution in Europe and not, for example, in China, or why was the Industrial Revolution in Europe and not anywhere else? Even more difficult is the question why it happened exactly in England. So these are open. I think these are still open questions. We don't really know. In sum, an important factor behind inequality between regions in terms of economic development is the timing of takeoff into subsequent technological revolutions. And of course, there are also factors that determine inequality within each specific era. And in this regard, I would like just to hint at, I guess, one important dimension of inequality that should be mentioned: factor shares versus the concentration of factor income. The standard economic approach would tell you that you have capital and labor. And so there is a labor share, and some of the output is directed towards the workers, some of the output is directed towards the owners of capital. And of course, capital is always much more concentrated than labor, because labor is something that you do with your hands, and each of us has 2 hands and 1 brain. So it's clear that labor income should be much more dispersed than capital income. So the greater is the labor share, the lower should be inequality. And another thing that emerges in the digital era is that we now have also returns to software, which is not embodied in our brains, but in programmable machines such as computers, smartphones, or robots. And the returns on software are naturally concentrated. They are probably even more concentrated than capital returns are, by the sole fact that information is non-rivalrous and can be costlessly copied. If you thought about the evolution of inequality across eras, you would say that within the Industrial Revolution, you first had an increase in inequality because of the accumulation of capital and the increase in the capital share. These were the times of Karl Marx and the exploitation of the working class. But then you had an increase in the scarcity of human capital, so the labor share overall increased again, and inequality decreased. And that was what was happening throughout the 20th century. Now, in the late 20th century, starting with 1970s, 1980s, we have seen a reversal in this trend. We've seen a further decrease in the labor share, and we've seen an increase in inequality, and especially in top income inequality. And what I would like to say is that probably one of the important reasons why this has been the case is that we now are observing returns to software, to computer software, which is concentrated, as opposed to human capital, which is in our brains, and therefore each of us has just one brain, and so the returns to our brains are naturally dispersed. Overall, in my perception, within era inequality is important, but between era inequality is really the main component of the answer to the question why some regions of the world, like sub-Saharan Africa or Southeast Asia, are poor, and other regions in the world, like notably Europe or Northern America, are rich. To a large extent, this was because Europe was the first to originate the scientific revolution and the first to originate the Industrial Revolution and the first to originate the digital revolution. So you see, sometimes as you once get this edge, further technological revolutions just make it more and more entrenched. So that, in my perception, is one of the key reasons why there is so much inequality between some regions in the world. That's all. Thank you very much. Please like, share, comment, and subscribe. Bye.